number is marine isotope state, and we also call it MIS1. And our research is during the MIS6 to MIS1, and we also correct the termination 1 and termination 2. And termination is a transition from a glacial to interglacial stage. So, what do we want to know? We also know AMOC is very important role to the climate. And the question is whether the AMOC has always controlled or at time only respond to climate oscillation during the last glacial. So our goal is to reconstruct of both the strength and the direction of the AMOC during the last glacial cycle. So from the high result marine sedimentary record in the deep western North Atlantic. So our sediment data is from OBP 10663, and this position has this position is the mixing zone, and it has a scientific record. And then I will introduce some two major proxies. One is neodymium, and this is the formula of the neodymium isotope values, and it is added from the Euro-manganese oxide, and its original source are the main source of it to save water. So this figure is another paper's figure, and I show this figure is just to show the different water mix has the different neodymium values. So next process is protactinium and saurian. So protactinium has long residence time, and saurian has the short residence time, and I will tell the details next. So this is fourth section of the Atlantic, and the blue is the saurian, and the yellow one is the protactinium. So the South Ocean has the high product than the North Atlantic, and we all know that they are most particular in the ocean. So and the saurian is more particular reacted, so it is rapidly to remove to the sediment. And the protactinium are removed by the NADW from the North Atlantic to the South Ocean. So in the South Ocean, sedimentary ratio is higher than the standard, and the North Atlantic is lower than the standard. So in short, the neodymium is we use it to reconstruct the direction and the major water mix, and the protactinium saurians ratio we reuse it to reconstruct the strength. So this is the various reconstruction model being established in the past research, and those three models correspond to the different isotope values, and like this. And we use this to construct, expand our result. So this result and this discussion. So we compression the termination 1 and termination 2's difference and similarities. So this figures horizontal axis is the age. It's the time series, and the bottom is the termination 2 time series, and the upper is the termination 1 time series, and the vertical axis is about the 2 proxies, and this one is insolation curve. So, and we can see the label. The right curve is the termination 1's data, and the blue curve is all the results about the termination 2. So we will show some different and similarity. And we can see this part is in the glacial maxima, and the positive neodymium values it index strongly SSW, and the value is decreased. So it indicates that the major water mass is to switch to the north sources water. And another one is the 2 termination is also have the hemorrhage event. So and this value, the protactinian Surian value is close to the production ratio. So it indicate that indicate that it has a very weakened NADW. So I'll show the 2 differences between the terminations. So one is we can see this the termination 2 didn't have the younger dryas like the termination 1, and the last difference is we can see this has a very positive neodymium values. So this end of the termination 2 has like the cold model. So, and the termination 1 is like the warm model. So next we distinct time interview of the different prevailing model of Atlantic deep circulation are documented in our research. So first, we look at this part, and this has a low protactinian Surian, and so it indicates an active and deep AMOC mode throughout most of the past 140,000 years. And we see these 2 stages, and we can see it has a very positive neodymium ratio, neodymium values like this. So during the last glacial circle has very draft occurrence of the cold models, and it only appear in the peak glacials. So the second, thirdly, so we can see the 2-part change. So we can see the significant shift in the MI3 is shift to the higher protactinian series values. So it is between the MI4, so 5 to MI4, it is the key period in the evolution of the AMOC. So our conclusion is, one is the deep and rigorous overturning circulation model has persisted for most of the last glacial circle. And whether has a shallower glacial model has seldom source water during the glacial maximum. And the next is the several weakness of North Atlantic deep water formation occurred only during the hemorrhage event, and it is the result of increased freshwater input. The next one is AMOC was relatively insensitive to some millennial water passed during the warm climate state. So, well, thank you for listening.
Okay. 11 minutes, 14 seconds. Hank. King Jen. Stop. Amy. Andy. Please ask question or comment. Give comments. Starting with Ken. Ken, please.
What is your I don't know how to pronounce it. PA species. Ratio pH.
You say this one.
Yes. So
What's your question?
How to pronounce it?
Just how to pronounce it.
No. I mean, what does it mean in your paper? Again, maybe understand.
It is a proxy, and we cannot directly to measure the temperature or the circulation of the AMOC. So we use a proxy to indicate to measure it.
To measure what?
To measure the string of the AMOC.
Okay, next. King Jen.
Can you explain the glacial period one more time?
Sorry. This is glacial period, and this is a spec map, and we use the oxygen isotope, and this is the proxy to measure the temperature, and the temperature is So this is so we can see the oscillation during this large time schedule, and we can see the change, the temperature change, and so what's your question?
What is 3A and 3C?
Oh, this is it's called submarine isotope state.
You put it there, marine isotope stage?
Yeah, but she said A, B, C. It's the
I don't know.
it's a little stage during the spring MI3. Yeah.
Okay, Amy. I'll come back to you later. Andy.
Less warm mode, cold mode, but what is off mode means? What is the off mode means?
Off mode. Oh, this one. Off mode means that is always appeared in the glacial stage, and it has a very weakening AMOC, and the major water mass is from the southern source. It's from source. Yeah.
Get it?
The major water mass is the Antarctical bottom water.
Okay, volunteer question. What's your name?
Sorry.
Sorry, okay.
You say that the AMOC will influence the climate or the temperature. So I want to ask if AMOC weakens will temperature in the northern hemisphere increase or decrease, and do you think AMOC will increase or decrease in the future?
Increase or decrease in the future.
And
I think this research is about very large time scale, and your question is about the future of the several years. So I think this research is cannot property of your question. But I think now we are maybe it's in the warm model, and the conclusion say in the warm model is so you can see that. So in the warm climate state is insensitive. So even though the iceberg discharge in the Atlantic, I think is the movie like the Day After Tomorrow's phenomenon will not appear. This is my opinion.
Okay, volunteer question, Annie. What's your name?
Roy.
Again?
Roy.
Roy, okay.
Can you explain the formula again?
Formula.
Formula.
Which one?
Which
Two of them. Two of them.
Sorry, which one?
S1 and
Neodymium.
This one.
yes. What is CHUR?
Which one? CHU. This is the standard of the neodymium, and this value is from the
Meteorite.
meteorite.
Is that okay? Any volunteer question? What's your name?
Pencil.
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 Okay, go on.
I want to ask whether the ratio of PA and TH can also show the direction of the current.
Also,
Yes, could this ratio also show us the direction of the current?
Oh.
Because
direction. Yeah. So like this. So if we measure this sedimentary ratio, and we can know a number, and if can you repeat your question? Sorry.
can this ratio also show us the direction of the current?
Direction.
Like what maybe means for this ratio?
I think it cannot show us the direction. Yeah. Because this neodymium show us the direction because of because of the different water mass has a different neodymium value, so we can measure the neodymium and to know the compose of the water mass.
Okay, my turn. Thank you. So this is the very first talk of this class, and she was very nervous, I think. And she also selected a challenging paper. So overall, I think she has done a relatively good job compared to all the other paleoceanographic talks I ever heard. But I think there's still quite some space for improvement. So I think it's nice that she has spent quite some slides discussing some terms, but this can be further improved. For example, you introduce the AMOC. I think there are several terms that you can further improve. The first is about AMOC, and here you show a map of it, but later you come to this statement that, where's that statement? You say it's important for the climate, which is
important. Oh, this one.
This one, okay. I think this is a bit too academic. Okay. I think what you can say is why this can be important for daily life. Okay. I think most of you would not have this feeling, but as a person who used to be in Europe, we know it's very important for MOC. That's the reason why most part of the Europe here, they are not as cold as other places, because they have the warm stream here. So it's very important. So that's something you can make it easier for the others. And then the same here, you try to discuss the glacial period. But if I were you, I would probably not show this one at the very beginning because everyone gets shocked. So I would probably use two images. One is maybe today, and the other is a glacial world. And then you can tell everybody that today it's quite warm, but actually in the past, the Earth has been much cooler or colder. And then you can look, you can show a figure like this, but I wonder if you can look for easier version, like without these numbers. Okay. Yeah, you just show this curve. Yeah, and you just say this is a very common proxy because this is not your main target. You just say this is a very common proxy for if today is glacial or not. Okay, so this means warm and this means cold. Okay, you can make it as simple as possible. Okay, then you spend some time talk about that side. This is okay. H model. This can be okay. You didn't show this one. Okay, you try to discuss neodymium. Okay, I think this is fine to show the equation here. But I think what has been missing, and actually later on you clarify during the Q&A session following one of their questions, is why neodymium can be used to trace. I think you show this image. This is quite nice because this is not from this paper, but you didn't draw a conclusion when you present the slide. You just say, somebody published this map, and that's it. Yeah, I think you should spend some time telling us, first, neodymium isotope, each different water mass has different isotopic value. That's the first thing. And second, you should at least give us some number. For example, if it's an ADW, I think, is it an ADW? I don't know why this protactinium and thorium ratio can be used to trace, I think it's upstream and downstream relationship, right? So at the end, you tell us that one can be used to show direction or rather water mass, and the other is the strength. Although I think so far so good. Although the full detailed logic is still missing, but I think this is enough for this class. Okay. And this one is actually quite critical, but I think you spend probably just 5 seconds on this slide. Okay, if I were you, I will spend time explain each of them carefully. Okay, so why under this situation the neodymium isotope is like that and the ratio is like that? Here it says high, 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 low, low, high. Why is that? Okay, because this is a working hypothesis of the author. So, if you have spent enough time to get them prepared for this, and why this situation connects to these proxies, then I think, because if you can do all this, you need to spend a lot of time in introduction. I will probably just present one most important figure. Okay, and based on your opinion, which one is the most important figure? Which one?
Most important.
Yeah, if you have only time to present one most important figure, and you have only time to present simple results, because you need to assume that they cannot really follow all the complexity, then you can only give a very simple conclusion based on the information you prepare for them. So I would definitely expand the introduction and shorten this. And if you say you want to choose this one, okay. This one is really complicated. Okay. So you probably really need to, I think this one would be helpful, like the way you do here. This one. You need to say, okay, under which condition this value corresponds to this situation. Then I think it will be easier for them to follow. I think that's for the structure of the slides. And then for the other comments, I would say these are too wordy. Okay. And if you can manage to write in your own words, yeah, like in easier words. These are all difficult. Restricted, sheet extend, what's that? Okay. So if you can really make them in easier words, this will be easier for them to follow in this class. Okay. And other pronunciation problem like the Southern Ocean mode, not model, okay, mode. And yeah, and then when you explain this, you have done in some of your slides. I think if you narrow down to one particular figure, you probably might want to explain them well. And then, because here it says low, high, you see, low, high, low, high. Maybe you can help them to say low, low, high. This is an inverted. Is it inverted? No, it's not inverted. Yes, it's inverted. So you have, yeah, so low, high, low, high. It's easier for them to follow. Okay, so let's thank Skye.